to do that. Balsam will look at the decarbonisation of cities. Darren's going to talk about decarbonisation of heavy industry. And Hattie will talk about power and how we can make power smarter to decarbonise the grid. And then we'll finish up and hopefully have a few questions at the end, if we have time. First of all, a word about who we are. We are DAR Group. We are a leading global professional services firm that has been around for over 70 years, and we've worked around the world with clients to design, engineer, and project manage some of the largest projects in the world to build sustainable communities. About 20,000 people almost, about 300 offices in 60 countries. So first of all, the challenge we face in terms of decarbonising our economies and decarbonising demand. And I'd like just to start with looking at overall global energy supply. If we look at global energy supply over the last decade or so, you'll see that net zero power generation capacity has grown by 30%, which is very encouraging. However, so has overall energy supply. As a result of that, fossil fuels have remained about 80% of total global supply over the last decade. So that's a challenge. And the challenge we have is to reduce fossil fuel production whilst our economies grow. So why don't we just cut production? And we have an interesting case study in Europe about what happens if you try that. On the left-hand side here, I have the European gas price over the last couple of years. Clearly, with the Ukraine crisis in Europe, gas supplies were cut significantly. As a result of that, the gas price rose by a factor of 10. And the burden of that, the economic burden of that fell on some of the communities that were least able to support that and caused quite a lot of economic hardship. It also, unfortunately, extended the life of some dirtier power generation capacity, such as coal-fired power plants in Germany, in order to make up for the shortfall. So just cutting supply results in a lot of negative consequences that can set us back. So if we're going to think about how we reduce our demand for fossil fuels, we need to think about what are we using them for. And these numbers here, this chart shows the overall supply of fossil fuels globally and what they're used for. 37% is used for power generation, and I think we can see, we have visibility of how that's going to be decarbonized. It's offshore wind, it's solar, and so on. But the remaining almost 60% is used in transportation, in industry, and in buildings. So we need to find net zero alternatives to fossil fuels for those sectors if we're going to reduce demand and therefore reduce fossil fuel supply. And that's really the challenge that we face. And it is a huge challenge. If we look at the last decade, emissions have grown 13% to 36 gigatons per annum now. To be on track with the IEA net zero 2050 scenario, we need to reduce that by 34% by 2030. So that's a massive challenge for us. If we look at current emissions, 40%, 41% from electricity and heat, again, we can see a path to that. But the remaining 60% from transportation, buildings, and industry, that's the pathway that we are working with our clients to try and decarbonize. And so if we look at the IEA future scenario of how it looks, how the world looks when we get to net zero, this is what these numbers represent here, the 2050 net zero energy situation. We're going to need a combination of both zero carbon molecules and zero carbon electrons in order to get to net zero. So why is that? Well, the zero carbon molecules, and what I mean by that is things like synthetic fuels, hydrogen, biofuels, etc. They're easier to store. They are higher in energy density, so for flight, That's a benefit. The negatives are that they'll need new infrastructure because they're new forms of energy, and as a result, they'll be more expensive than their fossil fuel alternatives. Zero carbon electrons, the great benefit is that they feed into all of the existing infrastructure that we have. That they're cheap and getting cheaper every year, but they're harder to store, especially in large volumes over long periods of time. And they are lower energy density, so it's harder to make them work in aeroplanes, for example. So some combination of those two is going to be the solution to decarbonizing buildings, transportation, and industry. as we see in this scenario. In buildings, energy efficiency is play a huge role in decarbonizing cities, but electrification also with heat pumps and so on. There may be a role for hydrogen, particularly for backup power. In transportation, passenger cars will clearly be electrified. Heavy road transport, there'll be a role for hydrogen, maybe for fleet vehicles, as we'll see with some of the presentation materials later on. For shipping, ammonia seems to be the solution that's going to be key for decarbonizing, and for aviation, synthetic sustainable aviation fuel. Heavy industry is probably the most complex to decarbonize. The key emitters in heavy industry are steel, cement, and chemicals. All of these will need some sort of carbon capture solution to fully decarbonize. But hydrogen will play an important role in steel and chemicals for process heat and as an input. And for cement, we'll need to change some of the input materials to decarbonize that, and then also use of biofuels and so on. So a range of different strategies across these sectors to reduce their demand for fossil fuels. But it's more than just about technology. If we're going to get to a sustainable and affordable and a secure energy transition net zero scenario, we can't just think about technology alone. And clearly it's important with solar and wind having a huge impact on power generation. But technology alone, without infrastructure to get it to the point of demand and to store it over time, is not going to be very effective. So we need to look at the electricity and gas grids, transmission, distribution systems, storage, fueling, and all of that infrastructure to enable this technology. The other key enabler is policy. Carbon taxes and credits are clearly having an effect in the US, and they'll be important everywhere. Standards and regulation to create markets for these new energy systems, planning and permitting so that we can get the infrastructure in place in time to have an impact. And then we can't forget the social dimension. It needs to be a fair transition. It needs to be spread across society. We need to think about public acceptance of some of these new forms of energy, hydrogen, for example. And we need to think about the safety considerations of working with these new fuels and how do we operate so that people are not hurt. At DAR, we are working with our clients to address all of these issues. On the supply side, DAR and Penspen have for some time been working on the infrastructure for electrification and for low carbon fuels. But on the demand side, all of the group companies are supporting clients in these sectors in cities and transportation and in heavy industry to deploy some combination of electrification, low carbon fuels to decarbonize these sectors. So it's really a core part of our mission and our story. And we want to now talk to you a little bit about some of that work and talk to you about how are we reducing the need for fossil fuel in these sectors. We're going to start with Matt, who's going to talk to us about designing transportation systems for zero emissions. We'll then take a look at planning and designing zero carbon cities with Balsam. Darren's going to talk to us about gas networks and decarbonizing heavy industry. And Hadi will talk about smart electrification to improve efficiency, reliability, and sustainability. So with that, I would like to ask Matt to come up and talk us through transportation.
Thank you. All right, which one goes?
That's forward there.
Okay. Greetings, folks. Nice to see you all. I am the CEO of TY Lin, which is the global infrastructure branch of the DAR family. We are a global engineering firm, and we've been providing infrastructure services to our clients for 7 decades in the transportation, buildings, and water markets. I also represent some partner brands, Introba, which is all about deep green engineering in buildings, and Lander & Brown in the aviation space. And we have, probably for the last 2 decades, been really focused on supporting clients in decarbonization and their ambitions toward net zero. And I think we're really well positioned from our legacy and also more modern work with clients to take us forward in the energy transition. I'm going to focus today really on kind of a higher level around projects and clients. There are plenty of smart people in this pavilion to dive into technology elements here. I'm not really going to get into that. But speaking of smart people, our very own Richard Palmer and Kate Sargent and others will be giving a deep dive into transportation here in this pavilion in a couple days, Wednesday afternoon. So a little plug for them. So let's move forward. Peter talked about this well. That really the 2 drivers of zero carbon in transportation or lowered emissions are around electricity and hydrogen for different purposes on the spectrum that you see here around lighter duty vehicles versus long transport, heavy duty, aviation, etc. When we get into hydrogen and other alternative fuels, but the key is that transportation is obviously a big driver in addition to power supply of about 25% of the emissions. So it's something that we really absolutely have to be focused on. There is a lot of innovation and transformation in this space. A lot of transformation in this space around electrification. Autonomous vehicles certainly is a real nexus with electrification, AI, and how that can affect our demand optimization and optimization of operations. Alternative fuels, whether hydrogen, ammonia, other things that are being explored, and alternative materials to be used in construction. There is a lot of cost and risk associated with implementing many of these solutions. So it's really imperative that government takes a lead role in driving regulations and stimulus. It's kind of a bit of a carrot and a stick situation. Peter talked about this a little bit. You see a bit of a patchwork of sort of regulations and guidelines on the right, depending on across the globe and across certainly the United States. There are various different ambitions that are either in regulation or in some sort of executive directive. And that's good, but hopefully across the road in the blue zone, we're working toward even more and more sort of unified guidelines in this space to take us forward. The funding is obviously an important aspect, and there's some great funding coming out of the United States and globally. This is important, and I think it's very well directed. However, it's really just the beginning of what we need to accomplish our ambitions certainly with the technology that we see today. This is just a down payment, if you will. So TY Lin serves our clients in this space in a couple key areas. Actually, a lot more, but just to talk about today, the fleet, infrastructure, and costs funding. We also work a lot in policy planning, workforce development, all kinds of other elements that are related to helping to decarbonize. But these are probably some of the key ones that are most relevant. Looking at the fleet, we have some really great tools that we've developed to work with clients on identifying the demand for various scenarios and various technologies, and how that converts to the fleet requirements for their vehicles. And you can see some charts here. The top one is sort of a daily use of a facility electrification needs. That's an airport. And you can see sort of the spikiness. That's obviously different than the needs that and the demand that they have today. So that presents challenges to consider during our design. The lower one is a transit facility, and that's actually over a period of time of about 30 years of the demand as it grows, and then the power that needs to be kind of provided in different segments over that time, and it's a significant increase in power demand. We talk a lot about personal vehicles and transit in this space. Obviously, aviation is a big driver of decarbonization. Others will be talking, I'm sure, about the actual aircraft and what that means. We spend a fair amount of time with clients working on electrification of their ground services fleets. And we've made some good progress there. You see SeaTac in Seattle and Syracuse Airport. Once we kind of get the demand and the fleet considerations understood, then we look at the infrastructure. What is the impact of that on what we need to build? What kind of facilities and infrastructure? And we look at various scenarios, oftentimes starting out with pilot programs, and you see there in the upper right a pilot program we're doing in Las Vegas around hydrogen fueling to really try to test out different methods and ideas. And then we implement the ultimate solution, and the lower picture there is a great project we did with Amazon where we provided about 800 chargers for their fleet in a project in New York. Well, there's obviously an impact to the grid and transmission and distribution for all of this. There are all kinds of projections about what it means, doubling, tripling the grid capacity. It's obviously significantly more than it is today, right? And what do the decisions that we make, how do they drive the requirements for the grid? You can see on the project that we did in New York for the MTA, that was a bus facility. The MTA is the biggest bus operator in the United States. They have about 6,000 buses. And it became clear early on in this process that the requirements to provide power to this facility were way beyond what was locally available within Manhattan. So, you know, there are projects, examples like that, and you can multiply that by hundreds and hundreds across the country of facility needs and what that really means to the grid. So we need to plan for that. We're also doing some interesting work in more remote facilities with commercial and industrial clients working on microgrids and renewable energy sources to provide power to their facilities. Cost is obviously very significant. Typically, there's an incremental cost that's associated with making an investment like this. Obviously, it's not all about cost. We're doing this for an important reason, but it's a very important driver for our clients. The example here that we see was a project that we were working on in Nevada where the incremental cost is about $1 billion over a 30-year horizon. That's significant and something that needs to be accounted for. Like I said before, the down payment is important that the government is providing. However, we need to recognize that you know, there's significant investment needs going forward. Okay, I'm going to have some colleagues talk more about the building space, but I did want to just touch on water briefly. TY Lin does a lot of work with water, wastewater clients, and there's a real strong nexus between energy usage and water with you know, the heavy demands that we have at water and wastewater plants. And I think there's a great opportunity here that's you know, starting to be tapped in a couple areas. One is obviously providing renewables at the power plants, and the second is better capturing and optimizing the byproducts, particularly methane in this example, to provide for cogeneration and other opportunities at wastewater plants. Okay, yeah, just looking forward into the future, tying this all together. Obviously, the next 10 years will be a pivotal, crucial time in the development of this technology, and I think we need to be very flexible, obviously, in embracing different technologies, working together, financial advisors, engineers, planners, policymakers, government, to work very closely together. We obviously don't know all the solutions today. We need to work together as they evolve and do the best optimum things for our clients. I may be a little bit biased as the leader of an engineering company, but engineers were born to solve these kind of challenges, right? The fuel source is going to be different tomorrow than it was yesterday. However, the civil engineering, the electrical engineering, the systems, the planning, the project management, delivering complex, large sort of challenges like this is what this is about. And we're really excited to participate and to bring our skills to solve those challenges. So with that, Peter, I'm going to hand it over to Balsam for our next section.
Thank you, Matt. Good morning, everyone. So I'll be specifically focusing on the built environment. Why? Because the built environment is about 39% today of our emissions. And because the built environment is going to be expanding by about 2.4 trillion square feet from now till 2060. So what this means, it means that we have to chart a path to make sure that we integrate energy efficiency, whole life carbon into how we approach the built environment moving forward to get us to the vision of net zero by 2050 and beyond. If we look at our cities and buildings, we look at a segregation of approaches. One that starts with the urban planning, so the wider development as a boundary, and then that zooms in into our buildings, our assets, what it takes to decarbonize them. Whether that means from an architectural perspective, a structural perspective, or an MEP perspective. So here specifically, we'll be looking at systems, their efficiency, electrification of buildings, and more. So starting with the cities. The approach to getting to net zero at a city level has to start from a top-down approach. First, we have to invest in passive design strategies. Those are the strategies that are there. They're readily available. Those are the strategies that our ancestors used to use a long time ago, from the way they used to orient buildings, to the way they used to integrate glazing, to the way that they used to lay out the buildings vis-a-vis each other, to the optimization of spacing between the buildings and so on. And also relying on strategies such as natural ventilation and the choice of materials specifically that we use for our buildings, part of that whole life carbon approach. Secondly, and that should always come next, is about integration of active efficient systems, whether efficient MEP systems, electrical systems, meters, and controls. After having done that is when we start looking at offsetting the rest of the demand that's required for operating our buildings and our cities, from rooftop PVs to on-site PVs to wind, geothermal, and others that we are heavily invested in considering. But one of the most important aspects of all of this is the users. How are we promoting the users' awareness? How are we training their behaviors, and how are we changing their behaviors in a way to adapt to operating those buildings in a sustainable manner? And how are we ensuring that during operation and maintenance, there are regular audits, there's regular maintenance that's happening to make sure that we always maximize the efficiency of the systems we have put in place? So some of the great work that we've been involved in is about really decarbonizing cities, and that's through a holistic approach. From the buildings themselves to integrating of innovative strategies, whether they are at a building level in terms of the architectural, the MEP design, or at an infrastructure level by integration of electrification of vehicles, by integration of smart street furnitures, and many, many others. And we've seen so far that before we get to speak about the buildings, that at a city level, we can achieve up to 60% reduction just by doing innovative, sustainable, efficient strategy integration, part of the tiered approach that I had presented. So within our boundary, we're able to do much, and that's how we'll be able to get to net zero eventually. We have to start from within, and we have to use our expertise being implemented to then impact the rest, because there is the 40% that remains out there that is related to the grid impact, having clean grids, having clean power, and having off-site farms. But if we are to zoom in at the buildings, again, it's a tiered approach. It's what the architects can do, what the MEP systems can do, and then the offset of the renewable energy. And here you see several examples, and I'd like to invite you to read one of the thought leadership pieces that we just delivered with PwC. This piece has 50 strategies, innovative strategies, that speak to what it means to decarbonize and what it means to get to net zero. What we did is that we analyzed each and every single one of those strategies. We assessed the cost, we assessed the efficiency, we assessed the delivery, the quality, impact on quality, and we assess the localization potential, which is very important. Because we operate in a region where potentially not all of the strategies will be readily available and will have to be imported, which sometimes defeats the purpose of implementation of a specific strategy in a specific project. So we went from looking at green steel, which is steel that is produced through green hydrogen, all the way to electronic smart glass, self-cleaning facades, dynamic facade, photobioreactors, and much more, really. And the importance of all of this is that this needs to be integrated into a clear roadmap, a roadmap that also looks at the HVAC systems in terms of heat pumps. So Peter had spoken about heat pumps used within buildings, which is something that we need to start shifting towards, and that's something that's not currently being very much implemented in the MENA region specifically. And then the integration of controls meters, which we're seeing more and more frequently these days, to be able to monitor performance, to be able to track leaks, and to be able to identify any deficiencies in terms of energy savings and lower energy production as we would anticipate during our design. And then to the decentralized solutions. So whether it's a shift to the decentralized power generation, we've also looked, for example, at trigeneration. It's one of the strategies that we have been investigating. On-site energy generation. So trigeneration is about producing heating, power, and cooling all together within a utility that will actually be supporting your project. To the decentralization of water generation, of wastewater as well, and of district energy. And all of these are systems that we have been studying and implementing in our projects and proving to be very much efficient in terms of actual operation. So for example, desalination at development level or treatment and reuse of water. Yesterday we've heard from one of our clients that TSE is used in all of the national parks in the UAE, and that's a great initiative. District energy sharing systems and thermal energy storage. And just to note that in Dubai, the regulation requires that 20% of your peak load is actually offset by thermal energy storage. And that's a regulation, so that's a must. So it's very important. And then the last point I want to tap on, because we're so much focused on our new buildings, and it makes a lot of sense because there's so much still to be built and so much still to be done. But we also need not to forget the existing buildings that are there. We need to make sure that we also focus, when we drive that roadmap to net zero, that we also focus on the retrofitting of existing buildings. Whether it's in terms of energy audits and assessments, energy efficiency, lighting, HVAC systems, improving of the envelope and the insulation, renewable energy integration, smart building technology, the water, and the life cycle assessment. And just to close my section, I've just selected some very few case studies where most of those strategies were either assessed, the feasibility study was conducted, and some of them were implemented. And I'll just focus on one random project per slide. So I'll go to the project that's very near to us here, which is the Saudi Pavilion at Dubai Expo. That's a project that was a LEED Platinum project that had the renewable energy, the materiality strategy, and the life cycle assessment that you've seen here, all implemented and considered. In terms of water, this project uses no potable water outside irrigation and 80% less of use of potable water to the inside. So that's an example. Another example is Princess Noor University. So this project has LEED Gold certifications, solar farms, and a lot of integration of local materials, renewable materials, and a very sustainable architectural, mechanical, and electrical approach. And with that, those are more projects here. I'll close my section and hand over to Darren.
Which one is it? Hi everyone, Darren Barton from Penspan, Energy Transition Director. Pleased to be here today. We're going to run through some of our case studies looking at what we're doing decarbonising industry. So first of all, I'll come back. Decarbonising the gas grid. Looking at hydrogen blending and repurposing. Hydrogen blending with natural gas is an essential step towards net zero. However, 100% hydrogen must be the goal. The UK, the EU, countries have already committed to hydrogen production. The UK plans for 10 gigawatts of low-carbon hydrogen production by 2030. The EU is planning 65 gigawatts by the same time frame. Blended hydrogen into existing gas network has significant advantages in providing a hydrogen market and taking advantage of the existing connection to users. Most equipment can tolerate up to 20% of hydrogen. Repurposing of the gas network, a significant opportunity, but presents some challenges. Compression will be a problem, will need to be changed out. Heat value is 1/3 of that of natural gas, and the hydrogen embrittlement requires different materials, a different risk profile to natural gas, and smaller impact area, but at a higher risk. There is an opportunity for use and considering the whole system, metering, pressure reduction, filters, and block valves. Decarbonising the gas grid in Europe, so the EU hydrogen backbone is a great example of what's happening. A master plan for continent-wide network of hydrogen infrastructure is being developed by 21 hydrogen operators. This will give a 55% net reduction in greenhouse gas emissions by 2030 alone, and neutrality by 2050. The investment is looking at $100 billion to $175 billion, and this will require subsea connections between Norway and the Netherlands, the UK and Ireland. This will also look at 53,000 kilometers of pipelines. 60% will be repurposed, only 40% new. Some of the case studies we're working on in Europe, from a Penspen point of view, with REN in Portugal. We're repurposing 1,400 kilometers of their gas transmission. They, by law, need to start blending in some renewable gases, mainly hydrogen, by 2030. Our objective is to perform the assessment studies and gap analysis in order to certify their transmission system with hydrogen down to the component level, all the way from the whole pipeline to the valves. And using code B3112, we'll be doing this, looking at the safety lessons, the hydrogen-related code and standards requirements, and using our in-house repurposing expertise. Two primary work areas for repurposing are, first of all, this year we complete 10% hydrogen suitability. We've just completed that. We now move into the second stage of looking at 100% suitability for the whole of the gas network in Portugal, which is, as I say, 1,400 kilometers up and down the country. Sorry. A second project we've been looking at, hydrogen blending. So blending stations up and down the country to feed level. This will now go to construction in the new year on a trial basis where they'll blend hydrogen into the gas network based on a concept and feed design that we've developed with our client over the last 12 months. Very, very important part of the hydrogen blending and repurposing network. As part of the EU, a trial in Portugal to start in the new year. In terms of industry, how are we looking at decarbonising industry? In 2021, the chemicals industry and the industry itself was emitting 9 gigatons of CO2, account for about a quarter of the global energy system CO2 emissions. Industrial energy consumption is still dominated by fossil fuels. We all know that. In particular, coal, which is surprising to some, and accounts for about a quarter of the energy-related CO2 emissions. As the global economy and population grow, the demand for materials and goods is increasing. And we have to have an importance of use and disposal of indispensable commodities. If we take the chemicals industry as a case study, almost 2/3 of emissions from the chemicals industry come from energy use. Energy is used to heat and cool reactions, grind and mix compounds, and transport this around the plants. Some can be electrified to renewable sources. However, due to very high temperatures required in the heating of some reactions, this is not always possible. And so alternative fuel sources are needed. In some reactions, CO2 is produced as a waste product of the reaction, which in many cases is unavoidable, needing carbon capture and storage. How can the chemical industry be decarbonised? There are top four energy transition technologies that we're going to look at. Process efficiency and optimization. This is looking at existing processing plant and how we can optimize and reuse and look at the waste heat. Secondly, hydrogen and alternative fuels. green hydrogen is produced by electrolysis of water. We are working with our clients, looking at the technology evaluation. What does that mean? Capacity, manufacturing. A big part of this will, of course, be ammonia. It's the current highest emitting primary chemical and use of green hydrogen. We're working with clients to look at green hydrogen products around the world. And then, of course, carbon capture utilization. Again, expertise we have looking at the technology evaluation, but also how you transmit CO2 from source to storage. And then finally, biomass waste as feedstocks. We're working on projects waste to energy. New forms of energy that you can supply into chemical plants as well. And just finally on this, 5 microeconomic challenges. Cost. Many energy transition technologies are emerging and remain costly. Infrastructure. Completely novel infrastructure is needed to implement these new technologies. Renewable energy. Green hydrogen, very important. We're working with our clients. But the green hydrogen and electrification is going to need renewable energy. Where's that going to come from? Is there going to be a supply shortage? Macroeconomics. We've seen over the last 2 years the challenges globally we face, not just in Europe, in the Americas, but obviously in the Middle East. And existing plants. Retrofitting chemical plants with carbon capture technology is expensive. Thank you.
Good morning, everyone. My part of the presentation will be about smart electrification, decarbonization of power, and smart electrification. So, as a recap from previous slides, the main affected sectors by energy transition are electric energy sector, buildings, transport, and the industrial sectors. As mentioned by Peter earlier, the power sector has already achieved decarbonization, is already advanced in that. The industrial and transport sector are still lagging behind, and this is why we need hydrogen and electrification to play an essential role in decarbonizing these sectors. This is a nice diagram taken from the IRENA World Energy Outlook 2022. It illustrates, in fact, the 6 technological avenues that will disrupt the 4 sectors that I just cited in order to accelerate the energy transition. The first KPI is related to the increasing share of renewables, actually, within the electricity generation. So it is projected to to increase from 26% in recent years to 90% in 2050, and this is to be in line with the Paris Agreement in year 2015 to achieve the 1.5-degree pathway. The second KPI is related to the increasing share of renewables within the energy sector, again projected to increase to 79%. The third KPI is directly related to energy efficiency of equipment. So they are projected to increase 6-fold from what we have today. Fourth KPI is related to the increase of direct share of electricity within the energy sector. So it will be increased from 21% to 50%, so almost 3-fold. KPI number 5 and KPI number 6 are related to the increase in carbon capture technologies and the increase of green hydrogen. So today I'm going to focus, or in the next slides, I'm going to focus on electrification from the end-use sectors. So what is electrification? Simply put, this is a process of converting the systems and technologies to operate using electricity as a primary source of energy. As I mentioned earlier, by 2050, around 50% of the global energy will be directly provided by electricity, so almost 3-fold. And the diagram on the right-hand side illustrates actually the transformation of energy mix between 2020 and 2050. So we can make a big statement at this stage that electricity will be the main energy carrier in future energy systems. So one might be wondering what will be impact on the infrastructure, and the result is that the impact will be quite significant. This is why there is emergent need for smart electrification to reduce the required capacity of renewable energy, reduce the strain on the transmission and distribution networks, and minimize energy consumption. So this is an example from electrification of mobility, which is, as explained by my colleagues, the transformation of the transportation fleet to electric vehicles. I take specifically specific examples of the impact of EV charging on a residential community, where we've seen that it has a direct result of having a hike of 30% on the power demand, and this is quite significant. I take another example from the electrification of heating and cooling, which is conversion to heat pumps, and to electrification of the food and beverage equipment to electric powered equipment. And again, on the right-hand side, a big impact on the demand load profile, where we see major shifts in peak loads between winter and summer times. So what's smart electrification? It's actually the integration of the advanced technologies, digital solutions, to enhance efficiency, reliability, and sustainability. And this is all for the purpose to reduce energy consumption and to reduce the strain on the transmission and distribution networks. So as an example, we can have intelligent devices, sensor communication networks, data analytics, all combined together to form a synergy with the purpose to achieve the said reduction. Another objective actually also is to enable the end-use sector's electrification through renewable energy. I take few examples of enabling technology. We have the vehicle-to-grid, two-way charging, microgrids, charging digitization, combined heat, smart grids, smart metering, and a lot of technology, just name it. Just to give you an example, but before that, a few words on systemic innovation. Innovation is in fact at the heart of smart electrification. This is why a systemic approach is required. So not only we should look on the technology itself, but on its derivatives as well, such as regulations, policies, business models, and system planning and operation. So all of these constitute the systemic innovation approach. As an example, I take charging as a service, and the benefit of that is that it lowers the upfront ownership costs of all chargers and softwares. It also allows service companies to have a wider base of charging points within a city, all of which accelerate the adoption of electric vehicles. Another simple example is the co-location of PV chargers with photovoltaic panels. If we take the example of parking, where the energy directly harnessed from the sun can go directly into the EV chargers and the vehicles, thereby minimizing the strain on the infrastructure network. Same goes when we couple cooling loads with the photovoltaic panels. So in fact, the cooling load happens, is at its peak when the sun is at its maximum at noontime. Another two examples that are more advanced when we talk about virtual power lines and when we talk about virtual power plants. What are these? They are actually locating battery banks, strategically locating battery banks and distributed energy resources within the grid, so that to minimize expensive expansion of the grid and minimize the additional having additional costs. Finally, a couple of examples to put the previous theory into practice. This is a net zero bus shelter that we have designed in-house in Dar. And the concept for the net zero approach is number one, we use the energy efficiency. Remember, this was KPI number 3 in the IRENA model. So we used reduced U value of the glass, equipment with hibernation mode, lighting control, occupancy sensors and daylight sensors, automation controls. And for smart electrification, we use smart metering for various systems, e-mobility, fast chargers with charging management system, battery banks, smart inverters with microgrid management, bidirectional metering, and interface with the ADMS. And for renewable energy, we used PV on the rooftop of the shelter. and the results were quite significant. In fact, we had 50% reduction in the total load, 50% energy saving, reliance 100% on renewable energy and net zero energy, reduced levelized cost of energy to almost 3 cents per kilowatt hour, which is quite a low number, and displacement of 30 tons of CO2 per saving per shelter. Another example of a business park in one of our African countries. Again, here we use smart electrification. We had 4 megawatt hours of battery storage, a microgrid management to manage actually the different sources of energy, which are the grid, battery storage, the rooftop PV, and off-site solar PV farm. We use as well bidirectional smart metering, SCADA and energy management system. For renewable energy, we had all the facilities equipped with PV panels on the rooftop, and we had an off-site wheeling from an agrivoltaic power plant. Again here, the results were quite significant. We achieved 20% reduction in the levelized cost of energy, 50% reduction in operational costs, 20% renewable energy penetration, and displacement of 1,200 tons of carbon emissions. Thank you for listening.
Great. Thank you very much to my panelists. Some fascinating examples of how to decarbonize energy demand there. I'll just sum up, and then I'd like to have some questions. I'll ask some questions. We'll have some from the audience. But we started by thinking about how we get to net zero, how important decarbonizing energy demand, the use of energy is. And I think that some of the cases we've heard here indicate that on paper we kind of understand how to do this, but when you look at it in practice, there's all sorts of considerations that need to be factored in that make this a more complicated issue than it may look at first. And for many of the clients that we work with, the energy has never been a strategic issue for them before. This is the first time they've had to think about things in these ways, and the solutions need to be developed. They're not there already on the shelf. We saw in transportation where working with clients on their fleets, trying to plan the energy demand is one thing, but then being sure that the grid is going to be there to support that is another one. We saw with buildings, we have a layered approach to building sustainable cities, but you also have to factor in behavior and people, and you need to think about the existing infrastructure as well. With industry and gas grids, the question is, when you start introducing new things like hydrogen and ammonia to these systems, how do the materials perform? What are the codes and standards? How do you do it safely? And then with smart electrification, again, it's a question of, what does the grid support, and how do you introduce this in a way that is sustainable and is measured. So a whole range of issues to be dealt with. What I find very encouraging, though, is when we think about the elements that we need to bring together to reduce fossil fuel demand, the technology, the infrastructure, the policy, and so on, we know what the answers are. They're all there. It's about bringing them together in a way that solves our clients' issues in a way that is sustainable, it's affordable, and it's secure. But we know how to do this. It's just about bringing those together in a way that gets to net zero. So, having said that, now I want to invite my panelists up. I think we're going to put some chairs up here in front. And then I'm going to we'll take some Q&A. So give me a minute. We'll get that organized. And Hadi, can you... Great, thank you very much. So Matt, I'd like to come to you first. I'm really interested to hear from your client's perspective when you start engaging with them on these energy transition, zero emission projects. What are their key concerns and thoughts about these issues?
Well, I think. Thank you. I'll trade you. Clients are, I mean, they're motivated by the stakeholders that they have, whether they're the users or political stakeholders or the community in general, and I think that they're very motivated to address the challenges that we're all talking about here, because it's the right thing to do, and I think they want to kind of be ahead of the curve and doing at least as well as some of their peers are doing. Their challenges are usually around the technology that we've been talking about here, and just trying to make a good decision that's going to be durable, which is obviously a challenge, and there's a lot of still some uncertainty, and cost. Cost is the huge driver. I talked about that. I think everybody talked about that. It's getting more. I suppose more economical as we go forward, like everything else. But there's still a big gap in the funding that's been provided and the real needs that we have. So, I'm optimistic that we just need to continue to innovate, and that's going to be the answer to really address the challenges that they're facing.
Great, thank you very much. Balsam, when we think about cities and decarbonizing cities, there's this concept of embodied carbon, the carbon that goes into building the cities. How do your clients think about that? And
thank you, Peter, for the question. I think it's starting to be a new trend and a new requirement that instead of just looking at the operational carbon, that everyone looks at the whole life carbon, which is operational plus embodied. And just to define what embodied energy is, just for the audience, that's the energy that goes from cradle to cradle. So when you extract your raw materials, you transport them, you make your material, you manufacture it, and then you install it, whether it's an architectural component, a structural component, an MEP component, or any system that you're using, a pump, a solar panel even. So the approach now, and us at DAR, we're advocates of this part of our commitment to net zero, that not only we're reducing the operational carbon, but we're trying to raise awareness as to the importance of also the whole life carbon approach, as to the importance of what are the materials, what are the choice of systems that you're making, that you're using, part of this whole approach. Because sometimes you might end up installing a system that makes sense from the operational perspective, but does not make sense in terms of the overall CO2 emissions from the embodied perspective. So this is picking up. We definitely can say that it's not very much advanced as to the level that we want it to, but that's what we're here for, right? We're here to influence our clients, to influence the communities, to make sure that they fully understand the importance of this, and to provide the technical assistance to support in making the right decisions on that front.
Fantastic, thank you. And thinking about the inputs to the built environment, cement and steel, clearly, industrial decarbonisation is a key element of that. Darren, how do you see sort of hydrogen playing a role differently in different regions and the investment in that infrastructure?
Thanks, Peter. Yeah, currently our consumption of hydrogen globally is about 100 million tonnes per annum. That's mainly focused in refining and ammonia. We've seen through our analysis that places in Canada, they have potentially 50 hydrogen valleys they're looking at and investing. That would match current demand of hydrogen. Whether they all go ahead and get the FID is another thing. Australia, very much second in that line in terms of advancing and developing hydrogen production. And these countries are looking at both green and blue hydrogen production. One thing we are seeing in Europe is that the industrial zones like the UK, Germany, Benelux are leading the green and blue hydrogen production, whereas places like Spain and Portugal and even Ireland, they're only considering green hydrogen production. Technology is key. At the minute, hydrogen production largely comes from steam methane reforming, autothermal reforming, so natural gas, hydrocarbons producing the hydrogen. And that comes in trains of 350, 400 megawatts. We don't have that in green technology yet. It's advancing very quickly, You know, we've gone from having electrolyzers that would be production in 1 to 5 megawatts. We're now seeing that double. And I expect by 2030, you're going to have large electrolyzer production facilities of 100 megawatts plus. It's all about economies of the scale. It's all about installation. It's all about reference plants, efficiency optimizations. But right now, the large hydro production is coming from the blue technology. And with that, you need carbon capture, which is another difficulty in that many regions don't want to consider carbon capture. But to get to where we need to for 2050, what is clear, hydrogen production needs to increase from today's consumption of nearly 100 million tons to nearly 20 times that, but to meet net zero.
And Hadi, fascinating discussion about smart grids. One of the things that I was wondering about that is, do you see more investment or engagement with smart grids from utilities or from the private sector? Because utilities are typically longer term in terms of taking on new technologies. But where do you see most of the interest in smart grids?
Thank you, Peter. I think smart grids is a combination of different technologies when we have different sources of energy, like photovoltaic panels, generators, batteries, different type of energies combined together. And a microgrid management actually combines all these and optimizes supply to the client, to the project, I mean, and as well reducing the energy cost. In order to answer your question, I think it's both applied in private projects. Whenever we have a small project, it could be applicable in a building, it could be applicable in a compound, and it could be applicable on a grid level as well. So the concept applies everywhere. Thank you.
That's great. Thank you very much. I'd like to take some questions from the audience, if there are any, before we finish. So if anybody has a question for the panel, raise your hand now. Anyone?
Thank you for the presentation. My question is, we have the potential or the vision towards decarbonization. How we are aligning our vision with the commitment, governmental commitment of the 2050 or that the governments at the Blue Zone are doing?
So I think just to paraphrase it, how are we aligning our decarbonization goals with the government pledges and commitments? I think, Matt, you kind of talked a little bit about that. Might be.
It's a great question, and I think we see as we move forward and really test the thesis around the technologies that we have today, that we need to make adjustments probably and recalibrations as far as what's achievable on what timeline and maybe what additional investment is necessary to achieve. And we seem to be kind of in the earlier days of recalibrating that, and you see sometimes the ambition is set, which is very important, and I think that does set a marker for industry and for our clients. But then we're faced with the reality of actually delivering on that timeline and with the resources that we have in hand. So, there's no perfect answer to your question, but I think it's a rebalancing, and again, I'd come back to investing in research and innovation and technology is going to be so important, because we just can't, we don't have the funding available to spend our way to address the challenges with the current technology. So we need to continue refining. Awesome.
I just want to add to that. I think, and to what you said, Matt, it has to start from within, right? Because if we don't show that we're walking the talk, then how can we confirm that we're 100% aligned? And that's why, as a group of companies, we're committing to net zero, right? We're committing to having the decarbonization roadmap implemented way ahead of their pledges in 2050, as early as 2030. And hopefully that together we'll be able to make it happen, right? By signing on to those commitments, by driving the solutions to make sure that those commitments are implemented. So I think that that's us as a collaborative, as a group of company, we can influence the decision makers out there, in addition to what Matt has said as well.
Yeah, just quickly on the investment side, I think we're seeing different situations globally. But what any investment needs, doesn't matter if it's renewables, hydrogen projects, you need a level playing field. You need to know how you're going to get a return on investment. So what is the cost of hydrogen? What is the cost of the feedstock? What incentives are there to invest in this new technology? What incentives are there, not just R&D, but to actually implement these large-scale green electrolyzer projects? We're seeing in the States there is incentivization, and when I talk about Canada being currently the largest forecasted producer of hydrogen over the next 10 years, it could quickly change to somewhere like the States or even the Middle East. But it's all about having that level playing field, like any project investment, that you know you can make a return on your investment, and it's a profitable business. Otherwise, you're not going to get the investment you required in the private sector for sure.
That's great, thank you. Any other? Great, Catherine.
Thank you. So you talked very eloquently about the challenge in terms of the energy transition, reducing transitioning generation and transitioning demand. Could you just talk about some of the resiliency measures that we need to take into account as well? Because the climate's becoming less stable. We've seen forest fires, we've seen utilities have grids taken out. So just to hear your observations about how we're increasing resiliency of our solutions.
That's okay.
So yeah, resiliency is a very important aspect, and thank you for that great question, Catherine. I think, well, definitely part of the projects that we're delivering is that we're focusing a lot on resiliency, whether it's through power backup, that we're doing solutions for that, or through water mitigation strategies, sea level rise, storm water management, flood mitigation. So there's a comprehensive strategy that we're considering part of our resiliency approach to complement the sustainability approach. And that's for all of these aspects, again, from power to water and beyond, to mitigate all of these natural disasters, and some of them human-made disasters also that we're facing every day.
Again, I'll answer from the power perspective as well. As I mentioned, there will be big strain on the demand on electricity, which will triple by 2050 actually, and there are a lot of measures that can be used to minimize that energy consumption, from using different types of technology to introducing renewables within the network. So different measures can be used to make to reduce the consumption, in fact.
I'll add briefly to that. This is a good question, Catherine, and I think as we endeavor to continue down the decarbonization path, the resiliency is something we are building in and need to build in every day, no matter what, right? So when we look at a transportation facility like a transit line, for example, in a metropolitan area, this is something that we think about. In addition to the all of the decarbonization issues we've been talking about, is just to secure that and make it as robust as possible for what we know and what we can predict right now.
Great, thank you very much. Okay, I think we have used our time, so I would like to thank our panelists very much. Some fantastic insights into how to decarbonize energy demand, and I would also like to thank you for your interest and your attention, and we'll leave it there. Thank you.